Hey, welcome to section 1.6. We're taking a break from computations and concepts and new vocabulary and just looking at a few applications instead. We're going to look at three types of applications in the videos. Those match the three types of applications that you'll be doing in your homework. Obviously, there's a million different types of applications, so this is a very narrow subset of everything that you can do with linear systems, but it'll give us a taste. The first one that we're going to look at is from economics, and it's from a guy that developed it named Leontief. If you read the opening example at the beginning of the chapter, you read a little bit about him doing his work in the 50s on a supercomputer that took like 56 hours and to do something that your calculator can do now in a few seconds. But let's see, where was that picture of him? Yeah, I like this picture of him because he's got one of his like 500 by 500 matrices behind him with some of the things blocked out where there's no interactions. But anyway, his basic idea was to divide the economy up into different sectors and look at how they related to each other and assume that those relationships were linear. So here's an example. So like I said, he actually split the economy up into about 500 sectors, but we'll simplify a little bit for the sake of your data entry. So suppose an economy has four sectors: agriculture, energy, manufacturing, transportation. And agriculture sells 10% of its output to energy, 25% to manufacturing, and it keeps the rest for itself. And so on for the other four sectors. All of them selling some to the other sectors and retaining some for its own use. And the idea here is to find an equilibrium. In other words, find a place where the output of each sector matches all of its inputs. Obviously, the sectors don't really work that way. Some of them are trying to make a profit and trying to avoid a loss. But the balance point is interesting to economists. It's helpful for them to then look at how far an economy is deviating from that balance point. Okay, so let's dive into a little bit. I think it'll make it a little more clear as we go on. So the first thing that the problem asks is to construct an exchange table for this economy. So let's go ahead and get started with that. So let's do where the material and the value comes from on the top, and let's do where it goes to on the side. This is pretty typical. So we have four sectors. We've got agriculture, we've got energy, we've got manufacturing, and we've got transportation. And same thing along the side. Energy, manufacturing, transportation. Okay, so looking at agriculture, it says agriculture sells 10% of its output to energy. So from agriculture, 10% of that goes to energy. 25% goes to manufacturing. And it retains the rest. So what's the rest? It's 25, 35, so 65% retains for itself. So 65% goes from agriculture to agriculture. And that means 0 goes to transport. Hopefully, at some point, a lot of agriculture will be creating biofuels that'll go to transport. But anyway, that's not the assumption in this model. Okay, so let's fill in the others. Energy gives 30%. Or sells 30% to agriculture, 35% to manufacturing, 25% to transport, and retains the rest. Let's see the rest now. There's 65, 85, 90, so 10%. Manufacturing sells 30% to agriculture, 15% to energy, 40% to transport, and retains the rest, which, let's see, the rest would be, there's 70, 85, so 15 manufacturing to manufacturing. And transportation, 20% to agriculture, 10% to energy, 30% to manufacturing, and retains the rest. So let's see, the rest this time is 50, 60, so there's 40% left. Okay, and I know this looks like a sort of a matrix already. I want to point out this is not actually based on a equation or a system of equations yet. It's just a way to organize the information that was given in the problem. So we have done that though. We have constructed an exchange table. That's what this thing is called. Now we'd like to actually find that set of equilibrium prices where the value of the outputs from each economy matches the value of the inputs. And to do that, we want to start by making this assumption that the value that agriculture produces, so A, is equal to the costs that they have to produce that. So that's the equilibrium that we're looking for here. Again, that's definitely not always the case. In real life, some sectors of the economy make a profit and others take a loss. But anyway, the agriculture, it is equal to 65% of itself. Agriculture also gets 30% of the energy sector, or I should say it needs 30% of the energy sector. It needs 30% of the manufacturing sector, and it needs 20% of the transportation sector. So now we're actually producing an equation here. I can do the same for the other three rows. Let me just point out before we get too deep into this, though, that at the moment my equation has A in two places. It's got A, it's equal to A, and then there's also some A over here on this side. Ultimately, when we set up a matrix and reduce it, I don't want A in two different spots. Right? I only want A in one spot. So I'm actually going to simplify, combine the A's. Let's see, let me just make sure I'm clear on what's going on here. We're going to subtract A from both sides of this equation. So the ultimate form of the equation I'm actually going to use will be 0 equals negative 0.35 A plus 0.3 E plus 0.3 M plus 0.2 T. And actually, really, if you want to talk ultimate form, and this is purely cosmetic, but just for the sake of my own comfort, I like to see the equals 0 on the right-hand side and the variables on the left. I think that's how we're used to doing our equations here in linear algebra so far. So let me just move the 0 over to the other side. Okay, so we need to do the same thing with the other three lines here. So we get 4 equations with 4 unknowns. If you allow me to skip a little bit, I'm going to say the next one would be E equals, and then I would subtract E from both sides and combine it with this 0.1 E over here. So hopefully this isn't skipping too many steps. If it is, let me know and I'll expand a little bit further. But anyway, the next line will end up looking like 0.1 A, and here's where we get the E moved over to the subtract from this, so this will be negative 0.9 E plus 0.15 M plus 0.1 T equals 0. So do that again 2 more times. Manufacturing equals A plus E plus, and then that's where the M, where the manufacturing will get moved over. So let's get 0.25 A Let's get plus 0.35 m. 0.35 m. Here's where we'll have minus 0.85 m. Oh, sorry, that's not an m there. That's an e. It's so easy to make typos on this. If you have made some typos, don't feel bad. I'm right there with you. Let's make this back into an e. And let's see, where were we? We're on the third row, and then 0.3 t equals 0, and the last one we'll move t over to the other side, so this equation will be 0a plus 0.25 e plus 0.4 m and then minus 0.6 t equals 0. So here's our system of equations, and homogeneous, by the way. If you were wondering in the last section, what possible use could a homogeneous system have, here's one. This is a homogeneous system of equations, and when we solve it, we will be able to find the prices where the economy is balanced. So now you can turn this into a matrix, remove the a's, e's, m's, t's, and equal signs, and dump that all into your favorite matrix calculator. I have that right here. I think I've got everything typed in properly. So go ahead and reduce that. Let's take a look at the, I don't like those fractions. Let's take a look at the decimal version, and we can round those a little bit. Let's see here. I can simplify this a little bit. Okay, so we had a first, so this would be a minus 2.03 t we'll do the same for the other equations. The next one would say that, let's see, the next line is e. E minus 0.53 t let's see, and the next one will be m. So that'll be m minus 1.17 t equals 0. And the last line, last row here is just 0 equals 0. It says t is free. So the last one is just going to say t equals t. And to fully finish solving this, let's write this in a vector form. Say the prices of agriculture, energy, manufacturing, and transport sectors. If I move these three t's over to the other side and factor a t out of the vector, I get 2.03, 0.53, 1.17, and 1 times t. So there are, of course, infinitely many answers to this. There are infinitely many prices where, for each sector, where the economy will be balanced, but they all have to fall into this relationship. Whatever transport is, manufacturing has to be 17% greater than that. Energy needs to only be 53% of transport, and agriculture needs to be twice as much, 2.03 times as much as transportation. So if T is 100 million, that gives you your prices for the other sectors of the economy. It's a simplified model, as all models are, and particularly as all models are in economics. In the other two examples, we'll look at some that are a little more precisely descriptive of their situations.